Hey guys, welcome to the session 2 of our chapter Lines and Angles that we are currently holding for class 9. This is a chapter 6. You guys remember we have already completed our portion related to the parallel lines concept. We had studied various concepts here. So we are going to do what? Let me just go to that and let's see what we had learned up till now. So before we get to this exercise, remember we had learned what were actually lines and angles. So you guys remember what were lines, right? So if you had infinite points, if you had a series of points that were falling on the straight path, then if you join all those points, that was your line. So it was simply like this, right? We had something like this. AB was a line, and in this case you can see AB itself here is right, a line here. So you guys see, if I just look at the line, so the term that I used to represent a line, it was this, that there are infinite points on this. So now you can guess this one if you're talking about the endpoints of line. You guys remember that since we were having infinite points, so there will not be any points, so any end points. So you guys see, these A and B are not the end points, they are just some points from those infinite points, and these arrows represent that the line can be extended on either side, right? So you can extend it on both sides. Then you had the concept of ray, right? So ray was what? Ray was the part of a line which had one endpoint but it was extending on the other. So if I had just taken this one A and moved towards B, so I could have crossed this B also, there could have been any other point. So you guys see, a ray will be having one endpoint, that means this one will be your endpoint, and it will not be having any endpoint on the other side. So that was the definition of ray. Then we had talked about our line segment. So line segment was what? It was that portion of line which was lying between two endpoints. So if I had just assumed these, the portion of the line between these 2 points, this right here, this AB, that will be your line segment. So remember, a line segment will be that portion of line which has two endpoints on either of its sides. So that was the point. Now you guys remember, we had what? We had then named them. So name of line was what? It was AB followed by two arrows. Name of ray was what? In this case it will be OE followed by arrow towards E because it was extended towards E. Then we had the line segment. It was quite easy, AB over bar, or you can say just an AB. So this AB means that we are talking about a line segment, but if you want to talk about your line, you have to represent it like this, but that does not matter. Then we had the concept of our angles, right? So angles are what? If two rays or two lines were intersecting each other such that they were sharing one common point, so the distance between any two adjacent arms, that means like this one or this one or that one, these were your angles, right? So in this case we will be having this as angle, that will be an angle, that will another be an angle. So let me just change the notation here. So this will another be an angle, similarly this will be another angle. So you guys see, we were talking about angles, then we had understood various concepts regarding those. So we had complementary angles, we had supplementary angles, we had corresponding angles, we had various of angles. So if I just draw parallel lines right here, so what were parallel lines? The pair of lines which had a common difference at any given point, or you can say the pair of lines which were not meeting each other at any given point, or they were not sharing any one common point. That means they were not intersecting each other, they were just having the same distances at any interval. So these two were your parallel lines right here, right? So in parallel lines we had what? We had our alternate interior angles, we had vertically opposite angles, we had corresponding angles. So if I just talk about this one, this is our intersecting line. So you guys see, whenever you had something like an X, so you guys see the angles which were facing away from each other, they were opposite to each other, those angles will be equal. So this angle right here will be same as this one. Similarly, this angle right here will be same as this one. So these kind of angles were what? They were your vertically opposite angles. Then if you had to talk about your corresponding angles, so these were the angles which were falling on the same side of transversal, but they were separated by the parallel lines, or you can say one angle was on the outside of the parallel lines, another will be inside. So these two will be corresponding angles. Similarly, these two will be corresponding angles. Likewise, these two will be corresponding angles as well. So you guys see, likewise this one. So you guys get an idea. Then we had alternate interior. So the pair of angles which were separated by the your transversal, like your line right here. So the pair of angles in parallel line which were separated by your transversal, such that they were lying on the inside of the parallel lines but were facing away from each other. Like this angle will be facing downwards, this angle will be facing upwards. Similarly, this angle right here, that will be facing downwards, and this one right here will be facing upwards. So these were your alternate interior angles. Similarly, you had alternate exteriors. So those angles which were separated by your transversal, but they were lying on the outside of parallel lines and they were facing away from each other. So like this one, this angle right here, that will be same as this angle right here. Similarly, that one will be same as that one. So these were all things that we had discussed earlier. So now we are going to do what? I'm going to begin with these. So I hope you guys can recall each and everything. Just one more thing, linear pairs. So you have to remember that also. So linear pairs were what? They were those angles. There were those angles which were lying on the straight line, such that there was a ray that was falling on that line, such that that ray was dividing this complete angle into two parts. So that was the whole point. They had one ray on either side and another ray on the either side, and there was one ray that was directly falling on it. So these two angles, if you add these two, if they amounted to 180 degrees, then we had two conditions. If the sum was 180 degrees, then this will be a line and they will be termed as linear pair. So we are going to use these things right here. So let's start with the first sum. This is quite easy. You guys should be answering this one real quick. Now you guys see, you have been given that there are two lines, AB and CD. So this one is your AB, and let me just change the ink right here, and this one is your CD. Okay, now you have been given what? You have been given that they are intersecting at O. Now you can see they are intersecting at O, such that angle AOC, that means this angle right here, plus angle BOE, that means this angle right here, together they are amounting to 70 degrees. Now to find out, and angle BOD, this angle BOD, that means this one. Let me just change the ink so that you can distinguish this. So this angle right here, that is 40 degrees. So this is 40 itself, and angle AOC plus angle BOE, together they are 40 degrees. Now we have to do what? Now we have to find out angle BOE, that means this angle right here, we have to calculate this one, and reflex angle COE. Now reflex COE, what will that be? COE, reflex, that means this complete angle. So we have to find out this complete angle also. We have to find this angle right here, and we have been given each and everything. Now what we are going to do, I'm going to erase this one, and I have been given what? Let's write given first. So I have been given that angle AOC plus angle BOE is equal to 70 degrees. Angle BOD is 40 degrees, and to find is angle BOE and angle COE, which is reflex. Okay. Now you guys see there are various ways that we can get around this one. So one of those ways is simply quite easy. See, I know sum of these two angles is 70, and I know if I look at this one, I have two rays right here, right? This is ray 1 and that is ray 2. So if I do what? If I have three angles with me now, right? So we have three angles. I know if we have one ray and we are talking about two angles, then sum of two angles, if the ray is falling on a line, that should be 180, right? Now you guys already know sum of these two angles is what? These two angles is 70. And if I just assume this one as my A, so you guys see A plus 70, that will be what? That will be 180. So you can do what? If you have assumed this one, then you guys know total angle on a straight line, that should be 180. So A plus 70 will be 180, and this angle will be what? 180 minus 70, that will be 110. That is the one method. Now with this, you have to find out reflex COE, right? So that should be what? This is the main angle. If you want to find out its reflex, then you will be doing what? 360 minus angle COE, right? If from this total angle I somehow subtract this angle, I will be having this reflex. So that will be quite easy. 360 degrees minus 110 degrees, that will be 250 degrees for the reflex angle COE. That is the method 1. And then we can find out the remaining angles also. So how we are going to do that one? Let me just erase this. So for that, now you guys see, if I just focus on these two lines right here, you guys see we have two lines, right? And they are forming sort of an X. Now you guys see their vertically opposite angles should be equal. Now I know this is 40, then this has to be 40, right? And you can look at this one, this total complete angle, this angle right here, that will be same as this one, right? Because we are talking about vertically opposite angles, and we have the figure like this, right? So this whole angle will be same as this whole, and this angle right here will be same as that one. That does not matter. We are going to ignore this line for a second. We are going to ignore this ray, OE as ray. We are going to ignore that one. Then we can see we have an X kind of thing, so we can use vertically opposite angles also. So similarly, we can do that one. So let's just see. I'm going to start with our method 1. I will be doing with both methods. Whichever you find easier, you can use that method. So for this, I know AB and CD are intersecting at point O. Therefore, angle AOC, that means this one, will be same as angle BOD, that means this one, which should be equal to 40 degrees. That is what? That is vertically opposite angles. These are the pairs of vertically opposite angles. Similarly, if I just focus on this one, you guys see, since we have to find out the reflex and we have to find this one out, so this is quite easy. I'm not going to do that one because we don't need that angle, although we can do it like this also. Now if you focus on this one, if you focus downwards on the line segment AB, so the line AB, you can see we have a ray OD and we have two angles right here, right? This angle and that one. Also, if AB, let me just write it, if AB is a line, if AB is a line, then we have what? We have this one, that angle AOD plus angle BOD, that should be 180. Why? Because of linear pair. I hope you don't have any doubt in this one, right? So this is quite straightforward. We have this one. So this will be the case. Now we have to find out the value of what? Angle AOD. So angle AOD will be what? It will be 180 minus BOD. Angle BOD, which is actually what? It is actually 40. So 180 minus 40, that will be 140 degrees. So I know this angle is 140. I know this angle is 40 because of vertically opposite angle. I know this angle is 40 itself. So if I somehow find this angle, then if I add all of these four angles, I will be getting the reflex COE. Now you get the point why I'm doing it like this. So I know angle AOC plus angle BOE, that is 70 degrees, right? This is right here. And I know AOC is what? AOC is 40. So angle BOE will be what? 70 minus 40 degrees. That will be what? That will be 30 degrees. So now we have this 30, this 40, this 140, and that is 40. Now you guys see, you just have to add this one. So this will be what? This will be 180, 180 plus 40. That will be what? 220, 220 plus 30. That will be what? 250. So reflex COE, that will be what? That will be 40 plus 140 plus again 40 plus 30. That will be 250 degrees. I hope you guys get the point why we are doing it like this, because we have just each and every angle on the reflex. So we just have to add those angles and we will ultimately be having the reflex COE. That is the method 1. Now we can use the method 2 also. So if I erase this one, so for method 2, that will be what? That will be quite easy. Angle AOC plus angle BOE plus angle COE. That will be what? That will be 180, since AB is a line, right? So sum of all these three angles will be what? It will be 180. So you can use this one. I know AOC plus BOE, that is what? That is 70. So 70 plus angle COE, that will be what? That will be 180. So angle COE is what? It is 110, and reflex COE, that will be what? Total angle 360, subtracting 110. So it will be what? It will be 250 degrees. So I have the reflex angle now. It is 250 degrees. Now we have to find out what? Now we have to find out angle BOE. So we know this one. I know this angle. Now I can use vertically opposite angles here. So we can just find out this remaining angle by subtracting it from 250. So this will be 40 and we can use that one. So 40 plus angle BOE equals to your 70. So angle BOE will be what? It will be 30 degrees. Or you can do what? You can just take the linear pair right here. You can find out this angle. Then you can again take the linear pair if you are not remembering your vertically opposite angles. So you can take linear pair right here. You will be getting this angle, angle AOD, but that will be 140. Then again, if you will be taking the linear pair considering CD as the line, then this will turn out to be 40. So 40, 140, 40, and remaining this angle x, all of these will be adding up to 250. So ultimately you will be getting the x, which will be 30. So you can use various methods around these kind of questions, but your method has to be correct, and the reason why you're doing that one, that has to be correct. So that has to be on spot. Now let's move forward and see what do we have now. So we have this question. This is the second one. We have xy and mn intersect at O. Xy is a line, mn is a line, it is intersecting at O. If angle POY, this angle right here is 90, and A ratio B is 2:3. Ratio between these two angles is 2:3. I have to find the C angle. Now this is quite easy. So if I just focus on this one, since xy is a line, then sum of all these three angles should be what? It should be what? 180. And out of that, I can see angle POY itself is 90. Then ultimately remaining these two will be what? That means angle A plus B, that has to be 90 degrees as well, because this is 90 and I can have two 90s in 180 degrees. So you guys see this will be what? This will be a 90 as well. So this will be 90. So I can use the ratios right here, put it here, put it against 90, get that value of x, then find out the values of A and B. And I know MN is also a line where A, I have this B angle, I have the C angle. Sum of these two angles itself will also be 180. So we can use that one also, or we can move around with this one also. So I know if MN is a line, then sum of these two angles, that means angle A plus 90, that will be same as this one. Sorry, we have to add this also. So, sorry, yeah, I think I've just, yeah, that will be the case. So you guys see we are having an x right here. So you guys see this A plus 90, that will be same as this angle, right? Now you guys know this is B. Then if they had asked this angle MN, then angle NOY, then you could have used your vertically opposite angles too to find this one out. So this is the easiest method that we can approach with this. So we are going to start with this one. So I know XY is a line, right? Therefore, we can do what? We can do it like this. Angle A plus, or you can say angle XOM, angle XOM plus angle MOP plus angle POY, that should be 180 because that's a line. So I know A ratio B is 2:3. So if I take ratio, let ratio equals to x. So A is 2x and B is 3x, right? That is the point. So if I just put it here, I know this is B and that is A. So this is B, that is A. So 3x plus 2x plus 90 equals to 180. So 5x equals to 90, considering this has been subtracted. So x will be what? 90 by 5, that will be 18 degrees, right? So it should be 18 degrees. So we have the value of x now. Let's just put it here. So 18 by 18 into 3, this angle right here, this will be what? This will be 54 degrees, and that one will be what? Subtracted from 90, or you can just do what? Multiply it with that. So it will be 36 degrees. Now we have to find the C. I know MN is a line. Therefore, B plus C should be 180, considering they are linear pair. They are the part of linear pair. So that means B itself was 54 plus angle C, sorry, plus only C. We don't have to use angle C because we have been given the name of that angle. This is C, that should be equal to 180. So C will be what? 180 minus 54. So this will be a 6 and it will be a 126 degrees. So I hope you guys understand this. So angle C will be 126 degrees, that will be 54, and this will be 36. So if we had to find this one out, that will also be 54 degrees using vertically opposite angles. Or you can do what? You can add these two, 90 plus 36, and you can still get 126 degrees. That will be same as this one. So there are various methods to get around this question. Whatever you find easier, whichever you find easier, you have to pick that one. Now let's move forward and see what do we have now. So we have this third sum with us. It is in figure 6.15, which is this one, angle PQR. PQR, that means this angle is same as angle PRQ, which is this one. Then prove that angle PQS, PQX, that means this angle right here, this one, will be equal to angle PRT, that means this one. And remember, this is a straight line. Now you guys see you have been given ST is a line, right? ST is a line. So you guys see, or we can do it with one other way. I will be using that method also. But first, if ST is line, then I can see these two angles are linear pair. So angle PQS, angle PQS plus angle PQR should be what? Should be 180, linear pair. Similarly, angle PRT plus angle PRQ, that should be what? That should be 180 as well. Both of them are same. So you guys see both of them are equal to same thing, and I know PQR is same as PRQ. So from 1 and 2, if I name this one, this is my first and this is my second. So from 1 and 2, we have what? We have this one. If I just do it, it is this one, angle POS plus angle PQR. That should be same as angle PRT plus angle PRQ. Okay. Now guys see, I know PQR and PRQ both are same, so they will be cancelled out. So angle PQS, this is Q. Angle PQS will be same as angle PRT. That is the method one, right? And this is quite easy. I think this is straightforward, so you can use this method. But if you don't want to use this one, we have one more. So you guys see, if both of these two angles are equal, and if I just find, if I do what, if I take this a parallel line, actually we will be having this kind of sum later on, so I will be discussing this method later on with the sum. For now, just use this one, the linear pairs, and you can just prove them equal. So this will be quite easy for you. We will be having this sum in our exercise 6.2, so I will be explaining it there. But for now, just have this method for you. Don't get confused in multiple ways. Now let's see what do we have next. So it is an important question. Remember, this is very important from your exercise, I guess 6.1. This is quite important sum. You cannot skip this. This has been asked. This is the most favorite question for teachers if they just want to put a question from exercise 6.1. So remember, this is quite important. You cannot skip this one. So we have been given what in figure 6.17, POQ is a line. I have been given that this is a line right here. The OR, which is this one, is perpendicular to line PQ. Now you guys know, if the line is if the ray is perpendicular, that means we are talking about 90 degrees angle, right? OS is another ray lying between ray OP and OR. This ray is one more which is lying between OP and OR. So we have to prove that angle ROS, that means this angle, is same as angle QOS. That means this complete angle, let me just change the ink, this complete angle minus angle POS, subtracting this angle. So the black portion right here will be same as half of, if I take this total angle, subtract this angle, and half that I will be getting the value of this angle. Now we have multiple ways for this question as well, but I don't want to confuse you guys with various methods. So I will be approaching with a simpler approach. So see what we have to do here. Firstly, look at this one. We have to prove this, and you guys see the thing that you can observe on your own. So firstly, observe anything that you can see with this question. I know I can see this is 90 and this is 90 as well. So that means this alone is 90 and sum of these two is 90 as well, and both of them are equal. So you guys see, if I just want to find out the value of ROS, how can I find out the value? One way is this: if I just subtract this this angle POS from this 90, right? I know angle POS plus angle ROS is 90 since this is perpendicular. So if I want to find out the value of angle ROS, that should be what? 90 minus angle POS, right? That will be the point. Now, if I do what? If I know this is 90, so I can write it like this. In place of 90, I can write it like this: angle ROQ minus angle POS, right? This is 90, so name of that angle is angle ROQ. That is same as angle ROS, right? So if I do what? If I add ROS here and add ROS here, so what do I get? I get this 2 angle ROS, that is same as, now guys see, ROQ plus angle ROS. This angle plus this angle will be this whole angle, right? So if I erase the portion from the figure, let me just erase this one. So you guys see angle ROQ, which is this 90, adding angle ROS, which is this one, I will be getting what? This whole angle, right? Which is O. QOS, right? That is the case. So angle ROQ and angle ROS will add up to angle QOS, and I'm left with a subtraction angle POS, right? So angle ROS will be what? Twice on the other side, half of angle QOS minus angle POS. So that is the proof that we had to prove. So you guys see, hence proof. So this is quite easy method. I think you guys will be understanding this method quite easier. We do have one more method. In that method, we are just doing it downwards up. We are going to use this one. We are going to use our angle QOS. We are going to expand that one. So we are going to pick this side up. We are going to do what? I know angle QOS will be what? Angle QOR and angle ROS. If we add these two, I will be having QOS, right? And here I know I can get ROS with one more way. That will be what? Let me just do with that method also. So you guys see, if I want to find out, I know angle POS plus angle ROS, that is equal to 90, right? Now if I want to find out this ROS, how can I write it down? I can write it down like this: angle ROS, sorry, actually this one. If I just do what? Actually, let's just write it like this: angle ROS, that will be equal to what? That will be equal to angle QOS, that means this one, minus angle QOR, right? Or we can do what? We can just do it one more way. See, if I just look at this one, I know this is complete. If I just do what? If I from this one, this 90, if I just find out, I know this is whole 180. See, this angle POQ, that will be 180, right? POQ will be 180. How? If I do it like this: angle POS plus angle ROS plus angle QOR, that will be 180, right? Now you guys see, if I just find out the value of this one, this will be what? If I just take this entire angle and subtract this one, so I know angle ROS can also be written like this: angle POR minus angle POS, and I know POR will be same as this one, so that can be written like that also. Then again you will be adding ROS on both sides, ROS here, ROS there, then you can easily do that one. So we have multiple ways, but I think the easier method is already discussed. That was your first one. You can use that method in order to solve this. So I will be recommending you guys to use that method, which is quite easy. Just value of ROS will be what? This, you guys know, this is total 90, so 90 minus this angle, so you can easily use that method. So if you have any doubt, just rewind the video and watch it again. So I'm going to move forward and see what do we have now. So now we are moving on with this chapter. There were some sums from your exercise 6.1. They were quite easy. You can easily do that one. But if you have any doubt, you can just log on to our website, get yourself registered. You can download our apps also. You can have tons of videos there which are pre-recorded. If you have any doubt in any portion, these videos might not be available later on, but those will be there. So you can just get registered and have those videos, and you can have doubt sessions too. You can have tons of practice papers too. So you just have to follow the link which is right here, which is studiacademy.com, and you can just get the link from for that app from our website, and you will be directed to your respective app store if you are on iPhone, and if you are using your Androids, then you will be having a Play Store. You can download that app and get yourself registered. We have a great offer running right now, which is quite cheap for you guys to buy it. So don't wait for that. Just log into that and get yourself registered. Now I'm going to move forward and see what do we have now. So this is our exam 2. It states that we have already, I guess, proved this one. So we are going to use this one also. So we have this: if a transversal intersects two pair of lines, then each pair of corresponding angles is equal. Now you guys see what they are stating, that if you are talking about parallel lines and there is a transversal, then their corresponding angles will be equal. Now we have this one: angle A is equal to angle E, angle C is equal to angle G, angle B is equal to angle F. You guys see this B will be same as F. One up, one inside, another up, another inside. So A is equal to E, then one down, one outside, another down, another outside. So these are the axioms that state this should be true. Now we can prove this one, but axioms are already assumed to be true. We are going to use this axiom and we are going to move forward with the theorem, and there we will be proving this. But you can use this one. See, this is your linear pair, this is another linear pair. this is another linear pair. So you can use these linear pairs and you can prove whatever you want to prove. See, first linear pair, this one will be second, and this one will be third, and ultimately this one will be fourth. You guys see, AB will be same as BD, and you have used your vertically opposite also. So you can use this one and you can use that one, and you know vertically opposite angles are already equal. So you can get the idea. Now we have this theorem. If transversal intersects two parallel lines, then each pair of alternate interior angles are equal. So we are going to prove this theorem right here. So we have this one. It states that if there are two parallel lines, let's say I have two parallel lines with me. First one is AB, second one is CD, right? And we have a transversal which is PS, or you can say PS is another line. So we are going to focus with this one. Let me just see. So we have to prove this one, that angle AQR. Firstly, you guys remember what are your alternate interior angles, right? So what are those? Those are the angles which are separated by your transversal, and they are on the inside of parallel lines, and they are having their faces opposite to each other, right? Like this one and that one. Similarly, this angle should be 3 and that angle will be 4. So these are your vertically opposite angles. Sorry, alternate interior angles. Pardon me. These are your alternate interior angles. Now we have what? We have to prove this one. That means angle AQR, which should be this one. Angle QRD, that will be this one. And angle CRQ, which is this one. And angle BQR, which is this one. Now you guys see, we will be using the corresponding exam theorem, which is quite simpler. So you guys see, if AB is parallel to CD, then and let's just write it completely. If AB is parallel to CD and we have PQ, which is transversal, so you guys see, according to exam, am I not audible? I think I am audible. Yeah, I am audible. So according to that exam that we have learned earlier, it states that the corresponding angles should be equal, right? So according to exam 2, pair of corresponding angles have to be equal. So I know angle PQB will be same as angle QRD. That means this angle will be same as this one. Similarly, angle AQP will be same as angle CRQ. That means this angle will be same as this one. Also, angle BQR, that means this one, will be same as angle DRS. And lastly, angle AQR, that will be same as angle CRS. Now this angle is same as this one, this angle is same as this one is same as that one, and that one is same as that one. Now I know if all these four pairs of angles are equal, and I also know according to vertically opposite angles, we have this angle AQP will be same as angle BQR, right? This angle will be same as this one. Angle BQP will be same as angle AQR, right? That angle will be same as that one. Also, angle CRQ will be same as angle DRS, and lastly, angle CRS, that means this one, will be same as angle DRQ. So I know, let me just write them neatly and let's just name them properly. So you guys see angle 1, 2, let's say this is 3, this is 4, that one is 5, that one is 6, that one is 7, and that one is 8. So according to this, I know angle AQP. AQP is which one? It is fifth one. So angle 5 is same as angle 2, right? And angle 6, which is BQP, is same as angle 3, right? So this is same as that one, and I know angle 7 is same as angle 1 and angle 8 is same as angle 4. So you guys see, I know also angle 3 will be same as angle 8 because they are corresponding angles, right? So that means if angle 3 is same as 8, then angle 3 will be equal to angle 4. That means this angle turns out to be equal to that one, right? So this is the first case. Similarly, you can use that one and you can prove angle 1 is same as angle 2. So these are the alternate interior angles that you have taken the help of corresponding angles and you have taken the help of vertically opposite angles too to prove them equal. So I hope you guys understand this, why they are equal. So that will be the scenario here. Let's move forward and see. So we have some examples based on that. So we have this one. In figure, L is parallel to M. These two lines are parallel. Let's just mark our arrows here. So these two lines are parallel to one another. And there is a transversal T. This is your transversal T. If intersecting at A and B, this is the point A and that is the point B, such that angle 1 is to angle 2, ratio between these two angles, it is 3 is to 2. Now we have to do what? We have to determine all the angles. Now you guys see, this is quite easy. We can do this verbally. Let me just write, let's just draw the figure here. So this is the figure. This is line L. This is line M. And these are the points A and B. And this is the transversal T. So I have been given, this is angle 1, this is angle 2, this is angle 4, that is angle 3, this is angle 5, that is angle 6, that is 8 and that is 7. So I know angle 1 is to angle 2, that is 2 is to 3 is to 2. So if this is 3x, that will be 2x, such that 3x plus 2x, that should be 180 because we are having a straight line and this is linear pair. So x will be what? 180 divided by 5. So this will be what? 36 degrees. So we have this angle will be what? It will be 108 degrees and this one will be what? It will be 72 degrees, right? So we have these two angles. Now I know this angle will be same as this one because vertically opposite angles. If this is 72, this is 72, this is 108, this is 1082. I know if we are talking about parallel lines and there are transversals there, then you can see their alternate interior angles will be equal. That means angle 3 will be same as angle 8. So this will be 72 as well. And this angle 108, that means angle 4, that will be same as angle 5 because they are opening their faces away from each other and they are separated by the transversal. So if this is 108, then this is 1082 too. And I know corresponding angles are equal to. If this is 72, you can say this is 72 as well. So if you did not want to use your alternate interior angles, then you would have taken the help of your corresponding angles and you would have taken the help of linear pairs too. But I know we can use anyway, we can use our alternate interior angles, we can use our corresponding angles, we can use our vertically opposite angles too. So you guys see, if this is 72, that one has to be 72. If this is 108, that one has to be 108. So we have the angles which are right here. So you guys see, we can easily do that one, or we can take the corresponding angles. So this was 108 and that was 72. So if I take corresponding angles, this is upward, this will be 72, this will be 108. Then I can take linear pair, this is 72, so this has to be 108, this is 108, this has to be 72. Now this is 72, this has to be, if I take linear pair here, this has to be 72 again. If this is 72, then this has to be 108 again because we are taking linear pair. So this can be done with that method also, or you can take the help of alternate interior angles. But since this question was based on the theorem 2, so it is better if you are using alternate interior angles, but that does not mean you have to use only that. You can mold the question or you can just use any method, any property, but you have to be sure that that property is correct and it is totally acceptable there. So you can use any way and you can do this one. Now let's move forward. So we have this theorem 4, actually the theorem 3 states that we have this theorem 2, right? So this stated that if the lines are parallel, then each pair of their alternate interior angles must be equal. Now another one is the converse of this one. That means if the pair of alternate interior angles are equal or their corresponding angles are equal, then the lines will be parallel. So that was the theorem 3. So I thought you guys will be remembering your converse also. So it is not necessary, just remember the converse. There is the same proof, you just have to have this downward up approach. So you will be moving from bottom up and you will be proving the remaining third theorem. So you can easily do that one. That theorem is just simple. that if the pair of alternate interior angles are equal, then the lines will be parallel. There are various ways to turn that around. We had just discussed that one in our earlier classes also, yesterday also. So you can just remember that also. Now let's move forward. So we have this: if the transversal intersects two parallel lines, then each pair of interior angles on the same side. Now they are what? They are your co-interior angles, right? You guys remember this. They are your co-interior angles, or you can say your adjacent angles. Now adjacents are different, just don't consider them as your adjacent, just consider them as a co-interior. Now we are talking about these angles, this angle BQ and this one is, or let's say BQR, and angle DRQ. That means these two angles, they will amount to 180 degrees, and these two angles right here, they will also be amounting to 180 degrees. So we have to prove this. Now you guys see, if I just erase this one, this is quite easy to prove since they are talking about supplementary. So their sum will be 180. Now I know if AB is a straight line, right? If AB is a straight line, then angle AQR plus angle BQR, that should be 180, and that is linear pair, right? Similarly, for CD, we have this one, angle CRQ plus angle DRQ, that will be 180, linear pair. And I know both of them are equal, so we can do what? We can do it like this also. I know angle AQR, that means this angle, is same as angle DRQ, that means this angle. Also, angle BQR, that means this one, is same as angle CRQ, that means this one. And why is that? Alternate interior angles, right? So in place of AOR, can I write it like this? Angle DRQ plus angle BQR, that should be 180, and this is the proof one. Similarly, in place of CRQ, can I write in place of actually DRQ, or you can just do anyway, we have to use AQR. So in place of DRQ, can I use this AQR? So angle, or you can use B, this one. Yeah, let's use this one and that one. So you guys see, in place of this angle CRQ, we have to write it like this, angle CRQ, and in place of angle DQR, we can use this one, angle AQR, that will be 180 as well. So you guys see, these two are 180 and these two are 182. So you guys see, we have just proved our theorem 4, which stated that if the lines were parallel, then sum of their co-interior angles will be 180 degrees. They will be supplementary. So I hope you don't have any doubt in this. Now let's move forward and see. See this one, the lines are parallel to each other. Now this is your actually theorem 6. This is your theorem 6, and theorem 5 is the converse of this one. That if the sum of the co-interior angles is 180, then the pair of lines are parallel. So that will be the converse. You can approach with this method and you can easily do that one. Now let's move forward and see. Lines which are parallel to the same line are parallel to one another. Now we have been given that if three lines in which two at a given time are parallel to one another, then the remaining line will be parallel to all. That means all three lines will be parallel to one another. See, I have been given that L is parallel to M and then M is parallel to N. We have to prove that L is parallel to N, or you can say each of these three lines are parallel. Now this point is quite easy to understand. We have just angle right here. You guys see, if L is parallel to M, then angle 1 will be same as angle 2, corresponding, right? And if M is parallel to N, then angle 2 is equal to angle 3, corresponding again. Now you guys see, 1 is equal to 2, 2 is equal to 3. So therefore angle 1 is equal to angle 3. Now if the pair of corresponding angles are equal, that means the lines are parallel. Therefore I can say L is parallel to N using converse of theorem 2. Right, quite easy. You can easily prove this one on your own, or you can simply say L is parallel to M, parallel to N. So I hope you guys understand this and you don't have any doubt in this. So this is the thing that we have to keep in mind. Now let's move forward and see. We have this example with us, 6.24. If PQ and RS, MXQ is equal to 135 degrees, this angle is 135 and angle MYR is 40 degrees, So we have to find angle XMY, which is this one. And let's say if they had asked you to find out the reflex of angle XMY, then we would have found this one. How we would be doing this one? So see, I will be doing what? I will be erasing this one. And see, for this method, just do what, since I cannot do it directly, I will be doing what? I will be marking a parallel line which is parallel to PQ and parallel to RS. And you guys already know, I know PQ is parallel to RS, and let's say I have a line AB such that AB is parallel to only PQ. Now I know if pair of lines are parallel to one another, then ultimately they will be equal to one another. So if AB is parallel to PQ and PQ is parallel to RS, therefore I can say AB is parallel to RS also, right? So this will be our construction. For these kind of sums, always try to have a parallel line. Now guys, see, if PQ is parallel to AB, then sum of their co-interior angles will be what? It should be 180. That means angle AXQ plus angle XAB, that has to be 180, and this is sum of co-interior angles. So AXQ is 135, so angle XAB is what? If I erase this one, so angle XAB will be what? That will be 180 minus 135 degrees, which will be 45 degrees, right? And you guys know the reason why I'm doing is this one. See, if I find out this one, if I find out this one, if I add both, so I will be getting the angle XMY. So this is my approach to this. Similarly, I know AB is parallel to RS, therefore angle Y, actually this is M, not A, let me just erase this one. This is MXQ, AB is the line. So this is MXQ, MXQ and XMB, right? So XMB will be the angle. We just move forward. So this will be XMB, and I know AB is parallel to RS. Similarly, YMB plus angle MYS. But here the difference is this one, or you can just do with this one. Let me just complete with this method. Now guys, see, we have this angle, we don't have this one, so we can take the linear pair and find out this angle MYS, which will be what? 140 degrees. So that is one way. Or we can do what? I know both of these lines are parallel, so their alternate interior angles have to be equal. If this is 40, then this one has to be 40. So we can do it like this also. So let me just erase this. So angle YMB, which is this one, and angle MYR, both of them will be what? They will be equal. Why? Alternate interior angles, right? So if this is 40, this is 45, therefore angle XMY, that will be what? 40 plus 45, that will be 85 degrees. And if you had to find out the reflex of that one, then subtract this from 360 degrees. So you can do with any method that you want. You have various methods to go with this one. Even if you could have done it like this also. See, you could have used only alternate interior angles. This is 135, then reflex will be what? It will be 45. If this is 45, alternate interior, this is 45. This is 40, alternate interior, this is 40. Together they are 85. So you can do it with this method or you can do it with that method. Choice is yours, but answer will be same. Now let's move forward and see. So if this is very important example from your NCERT, if a transversal line intersects two lines such that the bisector pair of corresponding angles, see, if the transversal intersects two lines such that the bisector of the pair of corresponding angles is parallel. First of all, we have two lines. Let's say this is line AB and that is line CD. Okay, let's assume this one. This is line CD. So there is a transversal. Let's say this is the transversal T, and such that it is intersecting AB and CD at two distinct points. Let's say this is point X and this is point Y. Now what is happening here is that there is a bisector of the pair of corresponding angles. See, if I assume this one, let's say this is the line, this is, let's say, XS, and this is, let's say, now first of all you have to identify your corresponding angles. I know This will be the pair of corresponding angles, or that can be a pair of corresponding angles as well. Similarly, you can move downwards and do it with that method, but I chose to have these two angles as the pair of corresponding angles. Now we have been given that, let's say this is YP, and we have been given that these two bisectors, these two are the bisectors of angles, such that if I just change the ink, this means this portion right here will be same as this portion, and this portion right here will be same as this one. Now we have to prove that if these two lines are parallel, meaning YP is parallel to XS, then we have to prove that one, that AB will be parallel to YD, or CD. Now required to prove is AB has to be parallel to CD. We have to prove this one. So remember, we have not been given that AB is parallel to CD. So we cannot use directly a corresponding angle property, although we can do it like this also. See, I know if the lines are parallel. Now you guys see, if I assume this one, if I just rotate the figure, it is like this. We have this and we have that. Now I know this is YP and this is XS, such that this line is extending. So can you consider, since these two lines are parallel, so if I just extend this one to a certain point, so I can see this line right here, which is T, it is acting as a transversal too. So you guys see, if the lines are parallel, then their corresponding angles will be equal. So this angle S, X, and let's say this is T, that will be same as angle P, Y, X, right? And I know there is PY and XS are the bisectors. So if this half is same as that half and these two are equal themselves, that means this half will be same as this half and also with this one, because these are the bisectors. So I can get sum of this entire angle will be same as sum of this entire, and you guys see this entire angle will be same as that one, and hence a pair of corresponding angles are equal, then the lines will be parallel. So this is my theoretical approach to this question. So I'm gonna start with the solution now. So if I erase this one, to see what we have to do here. Let's erase this one and start with the solution. So I know YP and XS are the bisectors of angles which are angle C, let's say this is Y and that is X, and angle A, Y, and let's say this point is W, for example. So angle AYW. So respectively, sorry, AXW, not Y, AXW, AXW, and I know XS is parallel to YP. It is given. Therefore, pair of corresponding angles will be equal. Therefore, if I do it like this, can I say angle SXW, that means this one, will be same as angle PYX, since T is transversal, right? So this part is same as this one. Also, if I do it here, I know XS, and I have been given that they are the bisectors. So I know angle SXA, let me just write it here. So I know angle XSA will be same as angle SXB, right? This SXA, which is this one, SXB, which is this one, they are equal, and angle PYC is same as angle PYX. These two are equal to, and I know angle SXW is equal to angle PYX. So if I just erase this one, I know if I just find out the entire angle AXW, what will that be? Let me just write it here. So I will be leaving this written at the bottom. Since we are going to use this one, I'm going to refer this one. So angle AXW, that is what? That is angle AXS plus angle SXB, right? AXS SXB, and both of them are equal. So can I write it like this? Twice of angle SXB, right? These two are angles equal, so that will be twice. Similarly, angle CYX, angle CYX, that will be what? That will be equal to angle CYP plus angle PYX. So both of them are equal themselves. So can I say angle twice of angle pyx, and I know sxw is equal to pyx, so that means they are both equal themselves. So angle cyx is equal to what? Now you guys see, if I just multiply this with 2 and multiply this with 2, both of them still be equal, because if you multiply equality to equality, your answer is not affected. Like if 1 is equal to 1, if you multiply this one with 2 and this one with 2 also, so 2 is equal to 2, right? So there is nothing wrong about it. So if I just multiply this one with 2 and that one with 2, so that means their double is also equal. So in short, angle cyx is equal to angle axw. So that means this complete is equal to that one. Therefore, AB is parallel to CD. So I hope you guys understand this. So this will be an important question for you to just recall this one and to practice on. So I will be wrapping up here. We will be starting our exercise 6.2 from tomorrow, and we will be having the remaining portion to be completed tomorrow as well. If we end up completing that one, then on Monday we will be having our practice session. If we are not gonna complete tomorrow, then most probably we will be having one more session based on this chapter on Monday too. Then on Tuesday we will be having our practice session. So till then, practice as much as you can. If you want to practice more, then you can just log on to our website like I told you, and you can download our app and you can just have the practice test there. But for that you have to get yourself registered, which is quite easy. Just follow the steps as mentioned there. Just download our app. You can have the doubt sessions there, you can have recorded videos there, and you can have as many practice papers as you want. You can have your test series also, so you can practice on each and every chapter, and then you can attempt the tests that are available there. So it is quite an opportunity for you guys. So just log on to our website and check out our offers. I'll be seeing you on actually tomorrow on Friday, and we'll be having the remaining portion then. Till then, practice as much as you can, and bye for now.